talk is hacking with the TPM. Don't ask what you can do for TPMs, ask what a TPM can do for you. And it's a kind of introduction into TPM and what you can do with it. And your guest host is Andreas, and here he is. Give a big applause, please. Thanks.
Yeah, hi everyone. So I'm Andreas. I'll be presenting some stuff on TPM. This is my GitHub handle and also my GitHub namespace where you can find some of the stuff or see what I'm working on. And the most important resource for everything I'm talking about is this web link, but you're going to see it in the conclusions at the end again. So who am I? Some disclosure. I'm actually working on TPMs. I'm being paid to work on TPMs, or I found someone willing to pay me to work on this stuff. And I'm also a member of the Trusted Computing Group, this industry consortium doing all the specification stuff. However, I started working with TPMs about like 13 years ago, when it was still 1.2 times. At that point, I was trying to get things working for me, and didn't work out too nice because the software was kind of, not too well maintained, and the API was sometimes a little hideous to work with. And so about 5 years ago, when the call for participants for working on a TSS2 came up, I basically jumped into the rabbit hole right away of what specification writing, negotiating, and whatnot in TCG, and also implementing the stuff and maintaining the stuff on GitHub later on becomes. And the results of this endeavor I want to present to you. So I'm going to go through some very minimal introductions to what TPMs are, and then we're going to jump right into those two topics of credential protection and some early boot protections, and then just some minor information on how you can get started working on this yourself. And here comes the fun part. So for your amusement and my personal adrenaline rush at late at night, I opted to go for some live demos. So what I'm going to be doing is I'll be going ahead and copying all this stuff, switching over into my trusted virtual machine here. And of course it doesn't work right away. So yeah, I should have unlocked sudo first. Yeah, so I'll be doing some live demos every now and then. Please don't DOS the Wi-Fi here, otherwise the presentation will get to a halt very quickly. Okay, what are TPMs? A TPM is basically a security chip that's soldered onto your mainboard. And thanks to Microsoft for giving TPMs to mostly all of us, basically for cheap, because thanks to the Microsoft logo program, every consumer laptop, desktop, whatever nowadays has a TPM, more or less. So why not make use of them? They are pretty high security chips, I would say. There's like some assurance from COM criteria certification, which you can trust, must not trust, may trust, but every evidence counts, I guess. Of course, there was some TPM.fails, and Tanya and David just talked about it about 2 hours ago or 3 hours ago, so it was very interesting. And what it's capable of doing crypto, which is what we're going to be talking about. It's capable of doing some storage, and it's capable of recording boot hash values. And that's basically all it can do. So it's a completely passive device. That's the most important part here. And on the right-hand side there, you see some old 1.2 versions of a TPM. Nowadays, the chip package is actually a lot smaller. Are TPMs dangerous? I think we've heard talks in the past at the Congress arguing for both sides. TPM's reputation when it first got into the market was these are these nasty, evil DRM devices that are going to remote control our PCs. As I said, they are completely passive. And what TPMs are in reality, first of all, they are an embedded smart card. So you have some kind of secure element in your PC that you can leverage. And then there is this whole integrity reporting and attestation capabilities that I'll go a little more into detail on later. But don't just take my word for it. Take Richard Stallman's or GNU Foundation's word for it, because they concluded that the Trusted Platform module available for PCs is not dangerous, and there's no reason not to include one in a computer or support it in your system software. So I would call that Stallman approved, and therefore, why not just go ahead and use it? All right, but let's get into the meat of it. Credential protection. Who in here is using public key cryptography in one way or another? And yeah, I'm basically expecting all hands to raise. Who is using a smart card or a YubiKey or a TPM to protect their credentials? Okay. And who has optimized this process by just leaving the smart card in there or cutting parts of the smart card out and wrapping this with Tesa? Or using a YubiKey Nano? Okay, those are only very few. For you few, basically this is the same assurance level that the TPM is going to give you as well. And for all others, well, smart cards, you can use a TPM instead to be more convenient. All of you who are not using smart cards but public key crypto, you should maybe consider using a TPM because you got one already and you paid for it, so why not use it? All right, what's the security idea of protecting credentials that comes with smart cards and TPMs similarly? Basically, we want to divide down our authentication or authentication guarantees into a proof of possession and a proof of knowledge. So we have two factors that are required or requested from us in order to authenticate. The proof of knowledge is pretty straightforward. It's entering a password, entering a PIN to unlock your smart card, whatnot. And the proof of possession is the second factor. Well, what does this actually mean? Well, what you need in order to create a proof of possession is you need something that is not duplicable or not clonable. So that's the primary feature of what the smart card gives you. What, for example, a soft token or a public key hanging around on your hard disk doesn't give you. Because you can just CP a software, a soft token file, and bring it to a different computer and have it run simultaneously on multiple computers. So by having something that's non-duplicable, you have something that can be in the possession of only one person at a single time, and therefore you gain this extra security. And this becomes especially important on every kind of hacker congress, like here or Black Hat or whatnot, because people around those conferences seem to be very good at recording passwords from looking at you typing them into your keyboard. So this is definitely a good argument to have the second factor. So the proof of possession which is usually like your smart card or your YubiKey Nano, can be basically translated into, well, we have a proof of possession of my laptop that contains a TPM. So only if somebody has access to this laptop and knowledge of the PIN, those two factors allow them to authenticate in my name or in the name of this credential. Typically the question is, but what if you're hacked? Well, this is a problem for every kind of proof of possession means. It's the same if you have a smart card in your smart card reader slot. For the time that somebody is able to control your system, they are able to more or less use your credential as well. But there's two differences. It's temporarily bound to the amount of time that you are hacked. So if you clean up your system, you can continue working normally again afterwards. And there's the second thing, there's no chance for an attack such as Heartbleed, where people would, because not every exploit is capable of gaining like full privileges. Sometimes exploits like Heartbleed are only able to dump certain memory pages out where maybe your key was living, and then you're screwed. You don't have that problem if the key is not known to the computer, to the CPU, and never stored in RAM or on disk. All right, demo time. How can you actually implement, or how can you make use of these credential protections? The simplest way to do so is with the TPM2 TSS engine from the TPM2 software projects. I probably should have mentioned that here. So that was one of the softwares that we installed earlier, and actually they did install. That's very nice. All right. In order to use that, all you need is these, I don't know, 3 commands, and therefore I just want to show them to you real quick. By the way, oh, I'm not using a TPM simulator, just wanted to show that I'm using an actual hardware TPM here. I just forwarded it to the virtual machine for fun and glory. All right. Virtual desktop switching. All right. So what we're going to do first is we are realizing, yeah, now it's working. We are generating a key using the for the TPM, and the next command is then we're going to generate a self-signed certificate. And as you can see, for those of you who've worked with OpenSSL in the past, the first command is a custom command of the software. The second command is just a regular OpenSSL create a self-signed certificate command with some mentioning of the engine and mentioning that we have a key form that comes from the engine, and that's basically it. So we're going to go ahead and take that, post that in here as well. Yeah, we're from Austria now. What? Who cares? All right. And now we have curl, and curl is actually capable of connecting us. No, come on. I should have brought a mouse. So curl is capable of making use of OpenSSL engines, and don't get irritated by the -- insecure here. I'm running an Nginx server right now on the host system, and from the virtual machine now I'm using curl to authenticate using client certificate authentication via TLS, and I guess everybody knows what that means, to talk to the Nginx. And as you can see, this is the website. And the first time I executed that command, I couldn't quite believe it because it was so fast, and I thought I made a mistake or something. So just to verify it to all of you, I'll be enabling trace logging. And then we see that we have a bunch of communication happening with the TPM. So we actually are using the TPM to do client-side authentication to the server. Thanks. Next thing. So this is so first of all, why I'm doing this. I'm of course doing this to scratch my own itches. So I want to be using TPMs at home maybe for like simple bash script based stuff. And whenever you're doing a bash script, you don't want to put your passwords in there, because when you push them to GitHub, other people will download them and use your passwords. Yes. So that's another advantage of these. And the second thing I want to be doing at home, I have some web server facing the internet that's basically a reverse proxy on Nginx that forwards stuff to Home Assistant and Octoprint and whatnot. And I want to enable this thing to store its credentials safely and securely as well, so the next Nginx heartbleed doesn't ruin everything for me. And for Nginx, it's actually pretty simple to do that. If we look into the sites enabled here, it's basically just the default site. We see that we had to post in the SSL certificate, and under the SSL certificate key, you can use this keyword engine. So hopefully you never store your key in a file called engine, because that's going to be a problem. And we point to the TPM2 TSS engine. And because of some hideous bug in Nginx that people on the Nginx forum have been talking about, but didn't find a good solution to fix it, we also have to specify the engine a second time over here. So once we have all that, we can just restart. We can just restart Nginx, and this time we're going to turn it around. So I'm going to go ahead and take my trusted web server on the host system, try to connect to that thing, and Yeah, because it's a self-signed certificate, of course, we don't trust it right away. But we just used the TPM in order to authenticate the TLS connection from the server side as well. So with both sides that we can now start scripting. Cool. Whoop. There we go. All right, so that's the easiest way to get started when you're trying to integrate TPMs into any of your daily bash routines or whatnot. The next, a little more complex way to do things is PKCS11. So PKCS11 is this standardized API by the Open Group that is what Firefox uses in order to talk to smart cards, for example. And of course, we're also working on, or this community is also working on something for that. We even have a maintainer sitting here in the room, calling you out there. All right, and we're currently in the 1.0 RC0 phase for this thing, which is also the reason why there is some weirdness that the setup tools don't install whenever you call make install. So if you're trying to like rerun this stuff from home based on these slides, note that this is a path into the checked out Git repository for the TPM2P tool. And the only thing that actually gets installed is the library, the PKCS11 library that's later on used. So anyways, we're taking these few commands here, and basically what we're doing is we're initializing. First of all, we're setting some Python path stuff and stuff like that. We're pointing to storing the database under home. We're initializing the database, adding a token, which is basically creating a new smart card out of nothing, and then we're adding a key. All right, let's see, is that running as well? Looks good. Yep. And there we have it. We just generated a smart card with this random whatnot smart card ID that you don't really have to care about. But what the cool thing is about this, and why I'm actually going into this problem, is I want to use that in order to authenticate via SSH. Because I don't know how many of you are using SSH client authentication using public keys? That's basically almost everyone. That's cool. Hacker Congress. So, and who of you is not protecting their key with a password, but using an empty password for that? All right. For all of you, this might be interesting. So what we're going to do is we're going to call SSH keygen. And what this is going to be doing is it's going to just, generate an SSH key. And you've probably all seen this. So I'm going ahead and copying this and going into my host machine. And here I'm going to edit the authorized keys. And I'll add this key. That's all. And going back to the virtual machine. Virtual desktop inside of a virtual desktop. It's like pimp my ride. All right, and then we can log in using SSH, and this should also be working now. And here we asked for the PIN for the smart card that I originally called label, which probably you can find a better name for that. And now I'm in, so it's working as well. But to make things even cooler, what else do we use SSH for? Well, we use it, or at least I use it, for Git together with SSH. So we'll go ahead, take this key again, and we're going to head over to GitHub. And this is my GitHub account. Now it gets interesting. So I'm adding this SSH key, and yes, I'm storing passwords. Hey, they don't have client certificate authentication. What else should I do? So the thing we're doing here is basically I'm creating this awesome shell script that contains of an SSH invocation with the PKCS11 library. And then we're exporting that under the git_SSH environment variable, which means that instead of SSH Git is going to be calling our new SSH thing, and this then translates to the to invoking the PKCS11 provider. So let's go ahead and clone. And here we have the TPM invocation again, and a lot more TPM invocation, and there we are. And we can now even go ahead and check out a branch. I think I've used this in my tests, so I'm just going to call it now. Nope. Of course. Check out a new branch. Git push origin. And it's pushed. And you can just go ahead, go to my namespace on GitHub, and you should be seeing this awesome TPM authenticated branch push over there. All right. As I said, this is RC0. Hopefully there's going to be a few hiccups and bugs that we're going to fix before the final release, but looks kind of usable, I would say. All right, coming to the next thing, which is highly work in progress. So basically, this is about BitLocker for Linux. And I've written this, I don't know, I think more than a year ago. And there was a merge request on the crypt setup upstream. And well, we're basically re-architecting the whole thing. But I just thought for fun and glory, I would bring this work that I did back in the days. So what this is doing, so for LUKS and crypt setup, the idea is you have a volume key that the whole volume is encrypted with, and then you have multiple key slots that are stored in the LUKS header of the partition, where this volume key is encrypted, usually with a key that is derived from the password you're entering. And this then looks like the thing we see here in the middle, where we have key slot 0 of this type and whatnot. And so what I did back then was I extended these. Yeah, this is JSON, so if you're using LUKS, at least in a new on-disk format, you have JSON in your partition headers, which is kind of awesome, actually, to extend. Made my life a lot easier at the time. So we have there a key slot, so something like that. And what we do is we take the volume key, and we use one of the TPM's non-volatile memory spaces, and we just store the volume key directly in there. And so there's yeah, nothing else we need to do. And then what we do for the on-disk format, for the LUKS headers, we're just storing some metadata. For example, what the NV index number is that we stored the stuff under. All right, so demo time again. And whoop. So this is the crypt setup branch that I checked out, and we'll be compiling this live. In the meantime, maybe one more note. So the operating system I'm running there in the virtual machine is just a standard Ubuntu installation, and I just chose disk encryption and LLVM during the Ubuntu whatever setup wizard. And however, unfortunately, that's still using the LUKS1 on-disk format. So what you have to do from the install media, if you want to do that, is you have to call this crypt setup convert that converts the LUKS1 to a LUKS2 format header. And then you should be ready to go. All right, so yeah, we compiled, we installed. Now we're updating the initdrumfs, just replacing Git crypt setup, who doesn't do that all the time. And the next command that we're running, and you will see that the only difference in the command is we're adding a --TPM here, which yeah, calls out to using a TPM slot for that. And we're entering an existing password. We're entering a new password. And this new password is then used for the TPM to authenticate. And we only have 5 minutes. So I'll just skip it right ahead. So this is now all set up, and on the next reboot, the system is going to ask me for the TPM-based password. And yeah, let's see at this. So what we see here is this second key slot is now of TPM2 type. All right. One more thing I want to present for early boot is integrity checking. This is based on what Matthew Garrett talked about at the 32C3, and this is the link to his talk. You should definitely go watch it. So this is about verifying the integrity of your early boot by sharing a secret between your TPM and your smartphone. And yeah, I just did a re-implementation. I'm going to showcase that as well. So in preparation for that, it's time for all of you to get out your smartphones and open your free OTP app or your Google Authenticator, so you can verify that everything works as intended. And this one I actually pre-compiled. By the way, if there's somebody in the audience who's good at GTK GUI design, please come talk to me after, because that was my attempt at doing this. All right, we're gonna be protecting by binding to PCRs 0 through 7. And this is going to basically validate on each boot that these PCR values were the same that they are right now when we are trusting the system. So that means if you have a kernel update or you update your init RD afterwards, there's going to be different PCR values. So you will have to go through this process again. So everybody has scanned this, hopefully, into their free OTP or Google Authenticator. Then we can go ahead and we can actually start rebooting the system. And hopefully this works now. Because the most complicated part about all of these demos was actually mode setting for Plymouth between Grub and Plymouth, believe it or not. All right, and there is this number, which is very large on the screen. So it was 828688. Was that correct? Awesome. And the second thing I'm doing now is, instead of the highly secure password Andreas, I'm typing in 1234. You have to believe me, which is the TPM password. And it's actually booting through using the TPM here, which is, come on, there it is. So that also worked with Lux. All right. I hope this gave you some impressions of what you can do with TPMs today already. If you want to get started joining the effort, joining to hack on stuff, this website up there is like our community page where we have a Gitter, so you can come talk to us, talk to me, talk to the other devils. You can have a look at those two header files, which are the most important ones right now. So the FAPI is rather new. We just released it, or just merged it into master, I think 1 week ago. So go ahead, have a look at that, test it thoroughly. Have a look at the tools. All the tools that start with TPM2 underscore are basically one-to-one mirrors of eSAPI or ESUS, and all tools prefixed TSS2 underscore are one-to-one FAPI mappings. And here's one more pro tip. When you're developing and something randomly fails all of a sudden, it usually has to do with TPM resource exhaustion. And this command down there frees up the TPM's internal RAM again so you can continue working. All right. Thank you.
Thank you. Thank you. That was Andreas. And it's question time. We have questions from the internet, and we have questions here in Clark. And look at it. You two have the same shirt. A very nice shirt, resource exhaustion.
Surprise,
Okay,
surprise.
so maybe we start with number 4, please.
Okay. So let's say you have your encryption keys in the TPM, and your favorite government is somehow influencing the vendor of the TPM. So there could be maybe some way to get the encryption keys. So this is not a good approach. So it would be nicer to enter your big fat mantra to get your keys, and they are XORed with some other keys that are in the TPM. And so you need to have both to decrypt your look stuff. So this should be made like this. So you could not let's say, take the person, torture the person, and try to decrypt the data on another computer because it has a different TPM without the secret. So you should have real two-factor authentication, not having the keys in the TPM, because I would not trust it.
Okay, depending on your paranoia level, but that's definitely a nice idea. Thank you.
Only having questions, please. No comments.
Okay.
Questions. That's the role. Number 2.
I have to use Windows, which is encrypted with BitLocker, and a second partition. How likely is it to accidentally destroy the credentials for BitLocker when working with these tools?
Well, that highly depends on which tools you're using for which purpose. The tools that I used here and everything that I showed does not install persistent keys, I think. No, actually, PKCS11 is installing a persistent key, so that drains some of your resources, and also the crypt setup stuff and the TOTP stuff consumes some NV space. And depending on how much of the TPM's resources Windows wants to claim for itself, you could run into resource exhaustion there. But other than that, there's no keys that these tools or the demos I showed would be deleting. So you can just go ahead and use those.
Okay, thank you. Maybe we'll have a question from the internet. Dear Signal Angel.
Yeah, other hardware tokens like a YubiKey, for example, they might have a button that you need to press in order to have some kind of proof of presence so that software cannot use it in the background without you knowing it. How to do that with a TPM?
Currently not, but I'm hoping, or I have been hoping for a TPM with an embedded LED for 10 years now. More likely, maybe we'll see some GPIO-enabled TPMs at some point in the future, and depending on what we can do with those, we might be able to include this or similar features in there. But so far, I think there's only been research prototypes. I once implemented a TPM on a Cortex M3 myself in order to demonstrate the usefulness of GPIO coming right out of the TPM, but that would need to be developed first.
Okay, thank you. Number 5, please.
Yeah, hi. Can you implement the universal second factor or FIDO2 and if yes, do you plan to do it?
Yes and no. You can implement parts of FIDO using a TPM, which is the basic crypto operation. However, FIDO also includes custom data formats that are usually also handled in the FIDO token, where you have some counters that you're incrementing, something like that, which the TPM does not store internally because the TPM doesn't know about FIDO data structures and vice versa. However, for FIDO2, I think there was this TPM attestation mode, but that would need to be implemented by someone. So if you want to start working on that, please come talk to me. I'll gladly be of help.
So there's a lot to do, and
Yes. So if any of you are searching for something to do, you can just go ahead and look at this GitHub.io community page. If you go to the software tab at the top and you scroll down, there is a list of programs. So we started with the programs that already have TPM support, and then we have an even longer list of programs that we wish had TPM support. So there's also other things like WebAuthn or WebCryptoKI or whatnot, where I would love to see more TPM support, or even as simple as GPG, which, yeah.
okay. Number 2, please.
How many different keys or smart cards can you store in a TPM? Is it just one, or can you save more in there?
The nice thing is that the principal concept of a TPM is that the TPM stores only very few keys. Usually it's just one in this case. And all the other keys are then encrypted with this key and stored on disk, on hard disk. So with this PKCS11 that we have here, you can have as many keys as you have hard disk space available, or as many keys as SQLite will allow you to store in a database with reasonable search times, I would say.
Thank you. Number 4, please.
Hi, thank you for the presentation. I have a question related to kernel upgrades. If I upgrade my kernel, is there a way I can measure what the kernel will be on the next boot and tell my TPM that just reseal the currently sealed keys with the future PCR values that it should expect on the next boot?
In theory, absolutely yes. That's totally simple. So a researcher will tell you this is not a challenge. The engineer is going to tell you, well, this is kind of a problem. And the problem is that you somehow need to know the reference values beforehand. And then you have to recalculate the whole measurement chain that went into that. And so this is a question of reference integrity measurement distribution. That there was also a track at the Linux Plumbers Conference tackling this problem. So this is mainly an infrastructure problem rather than an actual problem of the TPM or the TPM-based software.
Okay, thank you. So we just have 1 more minute, so I'm very sorry we can't take any questions more in the room, but I'll have one last question from the internet.
Yeah, if I don't trust the TPM in my machine, can I just solder in a different one from a more trustworthy vendor? Are they compatible in that sense?
Yes, as far as I know, they have a compatible pinout and a compatible SPI protocol, and that's the nice thing about standardization, is that they are compatible. So sure, go ahead. Except for maybe inter-PTT FTPMs that run in the management engine. Those, of course, if you solder those out, you won't have any I/O anymore.
Okay, thank you so much. If you want to get in touch with Andreas, go to the website. You've seen it before. And thank you for now. And maybe another applause for Andreas.
Thank you.